This video is going to walk you through the process of converting a remainder into a decimal when doing division of decimals with a whole number. And will require the use of adding zeros to the dividend. So what I'm going to do is just walk through three examples that provide three different scenarios in which you will receive a remainder, and that remainder will then need to be converted into a decimal and not leaving it in that remainder format. So for example, if we are doing 32 and 6/10 divided by 4. So our initial process is to divide the 4 into 32. 4 goes into 32 8 times. We want to make sure the 8 is placed above the 2 because it's the last digit of the number we were dividing into. 4 times 8 is 32. We bring down the 6, so we're just following our normal long division algorithm process. 4 goes into 6 once. 4 times 1 is 4, and we get 2. And we want to bring our decimal up into our answer. That's why it's really important about where you place your digits along the top. But you can't have basically a decimal with a remainder. A remainder represents a fractional piece, a decimal in itself. So it's almost like having a double decimal, if you will, not something that is actually accurate. So we cannot just write, R2. We cannot turn our remainder into a fraction because, again, having a decimal with a fraction is not going to be appropriate. So we need to continue the problem. We basically need it to where we don't receive a remainder at the end. So the solution to this is, because this is a decimal, I can add a 0 to the end and it doesn't change the value. 32 and 6/10 has the same value as 32 and 60/100. So if it is already a decimal, you can add a 0 to the end, does not change the value, but what it does allow us to do is continue the division process, bringing down another number. Now 4 divides into 25 times. 4 times 5 is 20. We've now gotten rid of our remainder. So 32 and 6/10, or 60/100 now, divided by 4 is 8 and 15/100. So that is one scenario where the inside number is a decimal and you just add a 0 to the end. For our purposes in 5th grade, we should not have to add more than 1 0, but if need be, for higher level math, you could just add another 0 and you could continue the process until you no longer have a remainder. So you get a 0 to that last subtraction problem, and it would just create a longer decimal along the top. The next example I want to go through, kind of going out of order here, but that's fine. 2 whole numbers. So I don't have a decimal anywhere. So 15 goes into 42 twice. I'm going to put that 2 above the last digit there. 15 times 2 is 30, and we're going to get 12. So 2 remainder 12. But the purpose of this video was how to convert a remainder into a decimal. So it is actually going to be the same thing we did up here. Now up here we added a 0. It didn't change the value, and that's our goal. So I need to add a 0 to 42, but without changing the value. And if I just add a 0, it becomes 420, completely different value. So the solution to that is to add a decimal point, then the 0. Still has a value of 42. So if the decimal point is already there, you can just add the 0. If there is no decimal point, add the decimal point, then the 0. And it's important to make sure to remember to add that decimal point in, because 42 has a completely different value than 420, and putting that decimal still keeps the value the same. Now I can bring down the 0. 15 is going to go into 120 8 times. 15 times 8 is 120. My remainder is now gone, and then the decimal, following our normal decimal division of decimal procedures, now moves up into the quotient. So 42 divided by 15 is 2 and 8/10. One final scenario is kind of actually combining two processes where we do have a decimal, but the decimal is now in our outside number, in our divisor. And you cannot have a decimal as your divisor. So what we need to do is we need to convert our 1 2/10 into a whole number. It needs to become 12. And how we can do that is by moving the decimal 1 space to the right, or what you're actually doing mathematically is you're multiplying it by 10. Multiplying it by 10 causes that decimal to move 1 space to the right. Well, if I multiply this number by 10, I also have to multiply this number by 10. So our problem ends up turning into 90 divided by 12. So I'd multiplied this by 10, so it could be a whole number, but because I multiplied the outside by 10, I had to also multiply the inside. So now we're just dividing 12 into 90. It's going to go in 7 times. 12 times 7 is 84, and we're going to get 6. But again, we need to convert that remainder into a decimal. So I need to add a 0, but I have to add a decimal point first since there isn't one, like in our example down here. Bring down the 0. Now I can continue. 12 goes into 65 times. We've now gotten rid of our remainder, and we need to move our decimal point up. So 9 divided by 1 2/10 is 7 5/10.